black holes. Regions in space where laws of physics are pushed to their limits beyond incomprehension. Hence, we face significant challenges in observing and understanding how they function. Mysteries of the universe could potentially stem from a four-dimensional black hole. It's astounding that humans have once observed the massive black hole at the center of the Milky Way with the naked eye, or that the gravitational nature of black holes challenges the understanding of the scientific community. These are just a few of the countless mysteries surrounding black holes that we are yet to understand or explain. The universe might have been created from a four-dimensional black hole. We still hypothesize the universe formed from a singularity point with immense mass, the Big Bang. However, scientists cannot explain where the singularity originated. Free researchers at the Perimeter Institute suggest that our universe started from the collapse of a gigantic supernova, part of which formed a black hole, and then drew in the remaining matter to create a singularity with immense mass. However, a standard black hole cannot capture all the matter around it, because the event horizon is a two-dimensional surface. Therefore, this black hole must have a three-dimensional event horizon, implying it is a four-dimensional black hole. Meanwhile, our current universe is a three-dimensional space, and we have no knowledge about this fourth spatial dimension. Nonetheless, scientists are very intrigued by this hypothesis because it is still a mystery that may one day be explained. It's incredible that humans have seen a massive black hole at the center of the Milky Way with the naked eye approximately 2 million years ago, a time when the supermassive black hole emitted bright light in a special event. At that time, humans were just beginning to evolve and stand on two legs. However, it's very possible that our ancestors witnessed this unique event in the Earth's sky. As we know, black holes have such a strong gravitational pull that not even light can escape, making it impossible for us to observe black holes in a conventional manner. Nor can they emit light like stars in the sky. However, at the time when a black hole is most active, it draws in a large amount of ceramic matter and forms a material disk heated by collisions at the black hole's mouth. At that point, hydrogen particles can be ejected perpendicular to the black hole's mouth and create a light explosion. Scientists have observed this phenomenon with two small black holes outside the Milky Way. When this happens, the light explosion can last for thousands of years and create a bright star in the Earth's sky. However, the supermassive black hole Sagittarius at the center of the Milky Way is now stable. We will likely never witness such a light show from a supermassive black hole again. The gravitational nature of black holes challenges scientists' understanding. To this day, many scientists still believe that SPIM is stable. It cannot be chaotic. However, a recent study by 3 Canadian scientists suggests that the gravitational field is like a fluid. It is chaotic, like water swirling down a drain. This theory helps explain the formation of dusty spiral disks when being drawn into a black hole. Yet, it also raises a question as well as curiosity among many. Does the center of a black hole have gravity? If it's like a whirlpool, any matter that touches the side of the black hole will be devoured. However, if approached perpendicularly, straight into the center of the black hole, may not be affected by gravity. Nonetheless, this is just a theory, and scientists still need to conduct more research, possibly real experiments with gravitational waves, similar to measuring wind in storms by sending probes near black holes. However, due to the vast distance from Earth to black holes, it will be a long time before we can fully explore the mysteries surrounding black holes. Shocked by the number of supermassive black holes in the universe. Black holes come in various sizes, some as small as a planet in the solar system, and some as large as our solar system. They are also very rare, supermassive black holes known as ultramassive black holes. Every large galaxy has a supermassive black hole at its center. However, in 2014, scientists discovered more than 100 dwarf galaxies with black holes at their centers. Dwarf galaxies are much smaller than the Milky Way, with only a few billion stars compared to 200 billion stars in the Milky Way. Yet, the size of the black holes at their centers may be significant. Astronomers had discovered a black hole at the center of the dwarf galaxy M62 with a mass 2 million times that of the Sun. Truly a monster. Based on these findings, some scientists believe dwarf galaxies are remnants of larger galaxies torn apart during collisions. However, they have yet to explain the existence of massive black holes at the centers of these smaller galaxies. Additionally, scientists estimate the number of such black holes to correspond to the number of dwarf galaxies that exist, meaning the number is very large. A black hole starts when a star with sufficient mass collapses into itself. However, the initial mass is only about 10 times that of the Sun, whereas the smallest black holes now have masses thousands of times that of the Sun. Normally, in their early stages, black holes attract gas and dust from the cosmos and nearby stars to grow. This process creates an accretion disk that supplies matter to the black hole. However, there is also a backflow effect during this process that makes the absorption of matter from the accretion disk very slow, reducing the growth rate of a black hole. According to scientists' calculations, in the early times, black holes could grow from 10 times the mass of the Sun to 10.0 times the mass of the Sun just 10 million years. Thus, if they only absorb matter from the accretion disk, it cannot be so rapid. This led scientists to hypothesize that black holes don't just stay in one place but move to hunt. Scientists believe that a newly formed, very active black hole has its own orbit. They move through the universe and rapidly absorb matter from new stars. Then they begin to slow down in activity. According to calculations, the limit of a black hole is 1 billion times the mass of the Sun. But the supermassive black hole at the center of the Milky Way is only about 4 million times the mass of the Sun. Smaller black holes are also voracious monsters. Until now, scientists believed that the larger the black hole, the greater its gravity and the more voracious it is. However, they had to change this view when they discovered Putin, a black hole only 1/15 the size of the Sun, but with a mass millions of times greater. Astronomers discovered the black hole 13 when it was devouring a huge star close to it, which was much larger than it. Astronomers calculated 13's ability to consume matter is equivalent to the mass of 100 billion frankfurters every minute. This is also proof that size is not important in the cosmic world. What is important is mass. They estimate that 13 will eat the nearby star entirely in about 1 million years, a relatively short time on the cosmic scale. Black holes can prevent the formation of new stars. Scientists have discovered that in ancient galaxies, a massive black hole can inhibit the formation of young stars. Young stars in the early stages of formation attract streams of cosmic dust and gas to their centers at very high speeds. After that, there is a cooling process, and this dust and gas stream is condensed to form a new star. However, according to recent findings, scientists predict that a massive black hole can affect this process. They see that in some red galaxies, there are only old stars, with no new young stars being formed. According to other research results, scientists suggest that this may be the result of a collision between two black holes at the centers of two different galaxies. The collision created a massive explosion that caused the dust and gas streams in the galaxy to be flung far away, leaving it without the materials to form new stars. Additionally, many believe that the very large gravitational pull of a black hole prevents the dust and gas from concentrating to form stars in smaller galaxies. The true mass of black holes exceeds our imagination. Scientists believe that the mass of massive black holes at the centers of galaxies is much greater than previous estimates, possibly 40% larger. Through observations and studies of the black hole known as ISWiki-18, scientists have further confirmed this belief. ISWiki-18 is called this because it has a massive dust disk around it, making it very similar to the live solar in the Lord of the Rings series. This black hole is located in the center of the galaxy named 4151. Scientists have calculated the distance from this black hole to Earth is about 13 to 95 million light years away. However, with a completely new technique, Scientists have been able to accurately measure up to 95%. The distance from Earth to the black hole, ISO 18, is about 62 million light-years away. Thanks to this new technique, they've been able to calculate the mass of the black hole more accurately, according to the results obtained. The number is many times greater than what we previously believed. Black holes are not the end-all of everything in the universe. When the gravitational force of a black hole swallows a nearby star, dust, and gas, one might think the star would be pulled into the black hole like water draining a sink. The streams of gas and gas drawn in at high speed heat up and emit light. They emit high-energy X-ray bursts that we can observe. However, while observing the galaxy Milky Way, astronomers discovered a high-energy X-ray burst similar to the activity of a black hole eating a star. But in reality, it was not. Astronomers later found that this was a neutron star, the remains of a dying star that isn't large enough to become a black hole. Neutron stars share some characteristics with black holes but are much less massive. They can attract dust and gas from nearby close ranges but lack the strength of the black hole. After this process, the neutron star will begin to cool and eventually become inactive. The mysterious disappearance of stars in distant galaxies is often associated with neutron stars, the remnants left behind from dead stars. They are characterized by very high rotation speeds and emit strong radiation, making them shine like lighthouses in the cosmos. Given the large number of dead stars at the center of the Milky Way, scientists estimate that there should be about 50 observable pulsars. In reality, they have only observed one pulsar within the galaxy. This peculiar anomaly has prompted various theories to explain it. One accepted theory is that the high-speed rotating pulsars have attracted dark matter particles at the galaxy's center. While dark matter is invisible and detectable directly, we can only detect it through the gravitational effects it has on other matter. Therefore, pulsars are invisible to us. Moreover, the accumulation of dark matter into pulsars increases the mass significantly, enough to form a black hole. Given the abundance of dark matter at the center of the Milky Way, it could contribute to the formation of many new black holes. A black hole begins when a star with a large enough mass collapses into its core. However, the initial mass is only about 10 times that of the Sun, while the smallest modern black holes have a mass thousands of times that of the Sun. In the early stages of formation, black holes attract gas, dust, and stars nearby to grow. This process creates an accretion disk that gradually supplies matter to the black hole. However, a counterforce during this process makes matter absorption from the accretion disk very slow, which in turn slows down the growth of a black hole. Meanwhile, calculations by scientists suggest that during the early times, black holes could grow from 10 times the Sun's mass to 10,000 times in just 10 million years. Hence, absorption from the accretion disk alone cannot account for such rapid growth, leading scientists to hypothesize that black holes move to hunt. Scientists believe that a newly formed, highly active black hole is its own orbit. They move through the universe, rapidly absorbing matter from new stars, and then they begin to slow down. According to calculations, the limit of a black hole is 1 billion times the mass of the Sun. However, the supermassive black hole at the center of the Milky Way is only about 4 million times the mass of the Sun. These discoveries continually reshape our understanding of black holes and the vast cosmos we inhabit, remind us of the incredible complexity and many mysteries that still wait to be uncovered.